Hello, mga ka-X! Welcome to our life! Are you sad? Are you hurt? Are you lost? Are you lonely? Worry no more. You are at the right channel. Welcome to Exclusives!
Hello mga ka-X! Welcome back to our channel. For today's video, we are now on Lesson 3.1 of Mathematics 10, and that is all about geometric sequence. To begin, let's define first what is a geometric sequence. A geometric sequence is a sequence of terms in which each term is obtained by multiplying the preceding term by a constant quantity. This constant is known as the common ratio. As an example, let's analyze the sequence of Anna's savings. We notice that each term after the first is obtained by multiplying by a fixed number, 2, which is the common ratio. Can you tell what is the next term? Elaborating further, here we say that a sub 1 or the first term is 15. A sub 2 is obtained by multiplying the first term by 2 that results to 30. A sub 3 we have 30 times 2 is 60. We get a sub 4 by multiplying 60 by 2 that gives us 120. For a sub 5, we can have 120 times 2 yields 240. Therefore, the next term is 240. To put that in symbol, we have R is equal to a sub 2 over a sub 1, where R is the common ratio, and a sub 1 refers to the first term or any preceding term. A sub 2 refers to the second term or any succeeding term. The symbol used a sub 2 over a sub 1 does not limit to the first term and the second term only. You can use any other consecutive terms to be substituted to the formula. Let's take a look at example 1. Find the common ratio of the geometric sequence 2, 4, 8, 16. Given that a sequence is geometric, just choose any one term in the sequence and divide it by the previous term to find the common ratio. First step for us to solve this: choose any one term to be divided by its previous term. Let's have a sub 1 is equal to 2 and a sub 2 equals 4. Then, the next step is substitute its corresponding value, then solve for the common ratio. Earlier, we have the formula for finding the common ratio, which is R is equal to a sub 2 over a sub 1. Substituting the values, we have a sub 2 which is 4 over a sub 1 which is 2. 4 divided 2 gives us 2, which is the common ratio. Note that you need to be extra careful with the placement of a sub 2, which is over a sub 1, when substituting their values to the formula. See, that's how easy to solve for the common ratio. The question now is how to identify whether a sequence is geometric or not. In this case, we need to divide every term by the previous term to find if it has a common ratio. This way, we can determine whether the given sequence is geometric or not. Now, let's have example 2. In this example, you're going to determine whether the given sequence is geometric or not. Let's start with A. The given sequence is 2, 4, 8, 16. So for our solution, this time, we need to divide every term by the previous term to find if it has a common ratio. Take note of the formula. We have R is equal to A sub 2 over A sub 1, where A sub 2 is the succeeding term, while A sub 1 is the preceding term. Going back to the first sequence, where A sub 1 is 2, A sub 2 is 4, A sub 3 is 8, and A sub 4 is 16. Our aim here is to identify if this sequence is geometric or not. So what we gonna do? Yes, we have to compute for its common ratio. So let's try the first two terms. Let's compute the ratio, which is A sub 2 over A sub 1. Substituting by the values of A sub 2 and A sub 1, we have 4 over 2, or 4 divided by 2, and that is equal to 2. Next, let's find the ratio between A sub 3 and A sub 2. Substituting by the values, we have 8 over 4, or 8 divided by 4. That gives us still 2. And for the last ratio between fourth term and the third term, we have 16 over 8, or 16 divided by 8, and that gives us 2. So as we can see, they have the same ratio. So therefore, we can say that this sequence is a geometric sequence. Hop in to the next sequence. 1, 3, 9, 18. Solving for the common ratio, we have R sub 1 is equal to A sub 2 over A sub 1. Substituting the values, that is 3 over 1, or 3 divided by 1, and that is equal to 3. R sub 2 is equal to A sub 3 over A sub 2, and that is 9 divided by 3, which is 3. For the last ratio, we have A sub 4 over A sub 3. Substituting the values, that is 18 divided by 9, which gives us 2. Upon checking, we notice that the third ratio is different from the other two. So therefore, we can say that this sequence is not a geometric sequence. So let's do a recap. A geometric sequence is a sequence of terms in which each term is obtained by multiplying the preceding term by a constant quantity. This constant is known as the common ratio. Well done, mga ka-X. That's all for now. See you in our next video lesson.
If you find the lesson confusing, feel free to hit the replay button. Replay! 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 Replay!